Hey everyone, welcome back to the YouTube channel. I'm really excited to do another video specific to the YouTube channel. This is not another live stream recording. And I wanted to do a video to show off a really cool project that I worked on this weekend. This is a project that started with a little bit of selfish inspiration, something that would help me a lot in a lot of the work that I do, but I think that there's a chance that what I did here can help other people in the community in their adventure to start Android development, which is building a template application for Android. Now, we already have this to some extent, right? If you open up Android Studio, I can create a template project that will have all of the initial setup we need, but it's just the out-of-the-box Android support. Those of you who do watch the live streams may have caught a recent one where I talked about developer experience tools that I think are really essential to every project. I'll put a link to that video as well as a blog post about those tools in the description below. But these are tools that I think help every single project. Even when I'm working on demo projects that aren't necessarily production apps, I think these tools are really helpful. So I decided to build a template project in GitHub that comes shipped with all of those tools out of the box, already configured for us to use. So I want to show y'all how you can use that template for your own projects, but then also do a detailed walkthrough of everything I included in that template and why. And then we'll talk a little bit about how you can customize this template to your own needs, how you can remove something if you don't need it, and then talk through the dependency setup in the first place, because I kind of followed a path to that I don't think I see a lot out in the wild in tutorials, so I want to make sure that it's clear why it's structured the way it is. So let's dive into this project. So I'll put a link to this below, but it's on my GitHub page, AdamMick331 /Android app template. And this looks like a standard GitHub repository, if you've ever seen one. And then there's a README here at the bottom that does a shortened version of this video. Actually, doesn't really cover a lot of this. I'll probably add the video, but it explains how you can use this template, what's included, some notes about dependency setup. But in case this all feels long and really wordy, that's what this video is for. I want to step you through the entire project and help you understand how you can use this for your own projects. So the first thing you can do is what's different from a standard GitHub repository is we have this use this template button at the top right. So if we click this, what's going to happen is we're going to see the new repository window come up on GitHub, and it allows us to create a new repository. And it's kind of like a fork, except it's not a fork. You're not going to make commits back into the template repo. You're going to start a whole new project that starts with the exact same code as this template. So let's say you wanted to use this. It could be for a production app. Let's say you're using it for some demo project that you're working on. So you type in the repository name, you can pick which organization that will be under. I'm going to make this private because it's just for video purposes, so I don't want to confuse anybody. I'll probably delete it afterwards. You can fill out your description. There's also this cool benefit of, including all branches. So right now the template repository only has one main branch, development, but if for any reason I want to maybe put like a template or like a customized portion of it on a different branch, then checking this box might be helpful, but I don't think we'll do that. So let's click Create Repository from Template, and now we'll see we'll have a new private repo here, AdamMick331 demo project. It'll say it's generated from this template, but now I've got everything from the template as my own new repository. And notice that even though the template had multiple commits to it, in this new project, we only have one commit. That's our initial commit. That's basically taking everything from the demo project. Now, once we've done this, we can go ahead and open it in Android Studio. Now, there's a lot of different ways to do this, but I'm going to show you one that I like to do, which is I'm going to go to this code button up here. I'm going to copy the SSH URL, and then we can go over to Android Studio. I already have it popped open here, but all we have to do is get from VCS, put the URL in there. We can change the directory if we want, but we'll leave it in demo project, and we can just go ahead and hit clone. And whoops, that opened on the other monitor. Let me bring that over. But now this will pull up everything from the repo into a new Android Studio project. So now I have everything I need to do to start building my own project. This is just like if I went into Android Studio and hit new project, except I'm going to get a lot of stuff that is not typically in an Android Studio template. And let's walk through what that is. There's a couple ways we could do this walkthrough, but I think what would be helpful, let me kind of highlight what's included and then work backwards on explaining how this is set up. So I included Ktlint and Detekt. These are two static analysis tools that I think are really important. We'll talk about them in detail later. We've got Git Hooks set up, we've got this Gradle versions plugin, we've got GitHub Actions set up, all tools that I think are essential to every project are in here. So how did we structure this? Well, what I like to do is inside the root project, there's this build scripts folder. You can see this on the left here. And inside of here, I have a Gradle file for each of these sort of concepts that I wanted to include. So this detect.gradle file, for example, includes all the configuration for the Detekt library. Now, one benefit of this, now if you decide to keep this template, a benefit of this approach is instead of having one really long build.gradle file in your main project, you've split up responsibilities. Like, I just want to take this responsibility of configuring Detekt, and I want to put it into this file. Similar to these other ones we're going to look at. Now, another benefit of this is if you don't want this in your own project, we could pretty much just delete this one file. And then we will have to go elsewhere where like the version number is defined and delete that. But I make it really easy to find the pieces that are included in the template and how we can delete them, or if you decide to keep them, you've got this nice organization setup. It also gives us another benefit, which comes inside our main build.gradle file, which is that we can see here where all of those build scripts files are defined. And there's a couple things to note here. So, whoops, I have versions.gradle in here twice. That's a nice mistake. We'll have to correct that in the template repo. But we've got, at the root level, we've got this apply from versions.gradle and githooks.gradle. And that's because these are groups of dependencies that really apply at the project level. For one project, I want to define all the version numbers. That's what's in version.gradle. And then the Git hooks for the project. Now, the nice thing about this sub-projects is a way to think about this is it will apply these dependencies to each module. So Ktlint, for example, this is a tool that will provide formatting, automatic code formatting for you. And if I have a multi-module app, I want every module, every Kotlin file in the entire project to have Ktlint. Now, if I were to put this, in the app folder, we have a build.gradle file. You may have seen this before. Now, at the top of this file, I could put the Ktlint information. But the downfall is if I made a new module, let's say we called it like analytics, we put an analytics module, then I would have to redefine the Ktlint setup in the analytics build.gradle file. With this setup here, we don't have to worry about that. You can add as many modules as you want and know that these 3 lines are going to get applied to each of those modules. So when I made the opinionated approach about these libraries are important and we should include them in every project, I also wanted to save everyone time and being able to grow into multi-module projects and not have to worry about this setup. I hope that makes sense. Let me know in the comments if you don't quite understand what's going on there. I can explain it. But another benefit of this is, so I mentioned versions.gradle. I think we need to go look at this file as well. So what we did in versions.gradle is I defined the version number of every dependency used somewhere in the project. And I also like to do this thing where I put the release notes as a comment above it, so that if there's a new version number, I can go to the release notes and try to understand what's new about that version number. But the benefit of this is similar to that sub-projects block. So how do I explain that? Well, if we look at the app build.gradle file, and we look at where dependencies are defined, well, look, we've already got some things that could be up to date. But you see they all reference like root project, versions, app compat. The benefit of this is the app compat version is defined in one spot. So again, if you extend this into a multi-module project, then when you make a new module, and let's say that new module also needs the app compat dependency, you can basically just add this line, and then the version number is still only defined in one spot. So if there's a new app compat version, we go into this file, we change it right here, and then all of our modules are updated automatically for us. So that's another benefit of this template. That's why the dependencies are set up in the way that they are, is so that even though, I myself, I typically like single module projects, but I know that's controversial. Um, but it's intended so that if you want to take this template and you want to scale it, the dependencies are set up in a way to hopefully support that well for you. And I think with that, I think that's it on the dependency setup side of things. So that's why these are like this. That's why we put everything in its own build scripts file, so it's easy to share across modules like this. Um, I would also point out that in the root level build.gradle, I did a similar thing. So these version numbers, they need to be defined here so that I could reference them inside like this dependencies block for the actual Gradle plugins. But the same idea, I wanted to pull it out so that it was easy to reference. And if I do need to reference any of these version numbers elsewhere in the project, then I should be able to do that automatically. So we've covered how to use the template. We've looked at how dependencies are configured. The next thing we can look at is really understand all of the dependencies I included and why they were included. So let's start with Ktlint. So if you are unfamiliar with Ktlint, this is a static analysis tool for code formatting. It's intended to prevent this idea of like bike shedding, is what it's called, where you really want to avoid any sort of nitpicky conversations amongst a team. So let's look at main activity for an example. This is the Kotlin file we have in the project, right? And, you know, it will automatically fix certain things. Like if we add a bunch of white space, we don't want like a bunch of lines in between functions like we see here. If your indentation is wrong like this, this is really bad. We don't want code that's like missing indentations. There could be other things wrong here. Even if I added like white space inside a function, this is valid, but we don't like this. So what Ktlint provides is a way to check that our code is formatted to the Kotlin style guidelines. I believe you can customize which guidelines it uses, but we want to check that our code is formatted. It also provides a way to format it if it's not. So the way we can do that actually is there's a Gradle task called Ktlint format. And if you run this, it will go over all the Kotlin files in your project and automatically reformat them, if it can. There may be some errors that are really egregious and the auto formatter can't correct. And if that's the case, it will put an error in the console, but otherwise it will correct it. Now, if we go focus on the IDE again, we can see all of our code slid back to the properly formatted spot. So this white space is now gone. This indentation and everything is all correct. So that's the Ktlint that we get out of the box in this template. Code formatting, I think, essential to every project. So again, a benefit of this template is you just start a new project with this template, and you've got this support out of the box. You don't even need to do any additional configuration. You just need to know that you need to run the Gradle task. But I've got something even better for you, which we'll see in a little bit. Let's also talk about Detekt first. So Detekt is a very similar tool, and I think I've heard this, that you can use Detekt for formatting and eliminate the need for two libraries. I'm not really familiar with that. I like to keep them separate, where Ktlint is for formatting and Detekt is for code smells. So what I mean by code spells is Detekt will check if you have too many functions in a file. It will check if you have complicated conditional statements, if your functions have too many parameters, things like that. And so the way we run Detekt is we just run this Gradle command, Detekt, and it will go over our project and tell us if there are any issues. Now, Detekt, thankfully, is extremely highly configurable. And that's based on this config file that's already in the project. Now, Detekt library provides a way to create a default configuration file, and that's what I've made, and that's what I've shipped with this project. However, certain apps will want to customize that configuration. So we need to open up this detekt.yaml file. And then I will just scroll through really fast. You can see this is a massive file. Don't be discouraged by this, because rarely will you have to like understand a lot of it. Really, you'll only come in here if you see Detekt failing and you want to try to figure out why or change it. So let's give an example. Let's say that you're writing some code. This can happen in Jetpack Compose actually, and then Detekt runs and it says, hey, this function has a long parameter list. It's got like 10 parameters. And we don't like that, right? That's a code smell if we've got 10 different dependencies. So let's look up that rule. There's a long parameter list rule right here. And we can see here that there's a whole lot of configurations we can make about these parameters. Now let's say we don't care about that at all. We can just turn this off and it will stop running this check for you. Or you could decide, well, 6 function parameters isn't that bad. Maybe I only want to alert if we have 10 or more. And this goes even further. We can choose to ignore default parameters. So if you have, say, 2 required fields and 8 optional ones, we could just toggle this and say that's fine. We could ignore data classes. So by default, this is actually on. If you have a data class that has like 10 parameters, that's okay, because that's kind of what data classes are for. And we can also tell it to ignore annotated functions. So I think a way to do this is like, if you have composable functions, we see this a lot in Compose, especially in the standard library for it, that they have lots of function parameters. We could tell this to ignore compose annotated functions. So that's what Detekt gives us. It really helps you keep your code maintainable and avoids code smells that you might not realize you're writing. So I find this tool extremely helpful. Hopefully you do too. And again, another thing that comes out of the box in this project. And as a segue, we can talk about, well, when should these run? And one argument, and we do this, is on our continuous integration environment. Whether we're using GitHub Actions or Bitrise or Circle CI, we want to make sure that our code is formatted and doesn't have any code smells. However, I like to be able to check that locally. I want to automate this process. And that's where this githooks.gradle file comes in. And let's actually take a step back. Before we look at this Gradle file, we should look at the hooks themselves, which is in this Git Hooks folder. So what this project has, this has a pre-commit hook, which looks complicated. Let me walk you through it before you get discouraged by all of this. All of this is saying is that when I go to commit code, before making the actual git commit, run through any changed Ktlint files, run the Ktlint format task, and then add them and commit them. And so if I write some code and I forget to format it, when I push up a commit, Ktlint will automatically format it for me. And similarly, I have a pre-push commit that's going to run the static analysis checks, which will prevent me from pushing code to the remote repository unless I've met all these static analysis checks. So this way I don't have to wait for, Bitrise or whatever service to fail. I will know as soon as I try to push code that I have an issue. So these two commit hooks, Git hooks, are already here inside this Git hooks folder. And the nice thing is we have this Gradle file, which will automatically install them for us. So what I mean by that, and this is, I don't know if I still need this, but at the time, this is my understanding. This only works on Linux or Mac OS. But if you need a Windows solution, drop a comment down below, and I'll try to make sure that we can get it working on Windows as well. But what this will do is this will take all of the files from that GitHooks folder, and it pastes them into the .git directory inside the hooks folder, which is where Git knows how to run these hooks. And then on Mac, it's not enough to copy the files over, but we need to make them executable. That's what this chmod does. And so this second task, install Git hooks, you notice it depends on copy Git hooks. So basically what this will do is copy them into the .git/hooks directory, and then make them executable. And now anyone on your team, all they need to do is run install Git hooks, and then they will see that that they have the Git hooks. So this sort of flow, this requirement of formatting code on commit, not allowing pushing code, this is a great way to share this across members of your team. And we can go an even step further with this in that we don't need to require them to manually install Git hooks if we use a little bit of a Trojan horse approach. Now, a huge shout out to Sebastiano, one of the members of Code with the Italians, who wrote this blog post up here. But we'll see if we look at our main build.gradle file, we've got this line right here, which says we install Git hooks at the first occasion. So basically this says whenever I run a Gradle clean, I also want to run install Git hooks. So let me show you that this works. So if I look at my hooks directory, if I list everything in it, we can see there's all these sample Git hooks. This is helpful if you don't understand what hooks are, you want to see what some samples are. But now if I run a Gradle clean on the project, and now if we look at that Git hooks directory, we can see the pre-commit and pre-push hooks are there automatically. So now your teammates actually don't need to do anything. All they need to do is clone this repo, run a Gradle clean, they'll get all that Git hook setup they need. So now up to this point, you can even do this if you're using this template, by the way. All you need to do is clone the template, run a Gradle clean, you're set up with formatting, code smells, and Git hooks to ensure that quality as you go. I think this is really cool. There's one more thing to this whole project that I really want to share, and that's a concern that I saw on Twitter, which was, dependencies become out of date, and keeping templates up to date is hard. And I'm sure that I will struggle with that, but I wanted to try to make that easier. And there's yet another plugin, which is this Gradle versions plugin by Ben Maines. And this is the configuration for it. Actually, what we can see here, all this is really doing is, so what the plugin does, a little bit of back context. What the plugin does is it will take all of my dependencies and tell me if there are new versions. And that's what you get out of the box just by applying this plugin. Now, I like to do an additional configuration, which basically says reject new versions if they're not stable. So if 1.0.0 is the most stable version, but there's, say, a 1.1 release candidate, I don't want this plugin to alert me on that. So all this is saying is this will reject new versions if it's not stable. Now you might want to reconfigure this, and again, that's the benefit of putting in its own Gradle file. It will be easy for you to find. You can customize how you use this plugin, but that's what I like to do. And so if you want to use this, what we can do is we can run Gradle W dependency updates. And this will do two things. The first one, so it's going to check all of our dependencies in the project and check for any new updates. It will even check your Gradle version itself, which is really cool. We're going to have to wait for this to run. Great. So this ran, and we can see everything in the console here, but we can also look at the, is it inside app? Inside app build report, we can see all of that output here as well. So one nice thing about the text file, if you want to write some additional service that reads from a text file and, say, alerts you about things that have new dependencies, there are ways to sort of parse this data. Maybe that would be a separate video or blog post. I think that's really cool. But we can see here, like, the biggest thing about the template is there's now a new compose version. This is also my first time hearing about this one. I didn't know 1.0.4 was out. It looks like we could update our Ktlint version. Also, our Gradle version could be updated. So again, this is a plugin that you get out of the box with this template. You can take this over. If my template is not up to date with dependencies, once you create a new project, you could run this right away, see what needs to be updated, get everything up to date, and then you're ready to get started on your own projects. And the last thing included in this template, if you watch this video, congratulations, you don't need to pay attention to this next part. But if you want to share this with your friends, which I would appreciate, there is a documentation folder where I went over everything I just told you. I missed something. I'm glad I looked at this documentation folder. The only thing I included that I didn't share with you was the GitHub Actions, so let's talk about that. What these documentation files are is um, I document the importance of Git hooks and how to use the Git hooks that have been included in this project. I talk about the pre-commit and the pre-push and why those commits do what they do. We have a static analysis markdown file. This explains what Detekt is, why we added it, how to run it. What is Ktlint? Why did we add it? How do we run Ktlint? Same thing with the versions plugin. What does it do? How do we run it? So if you're sharing this with someone and they don't want to watch this whole video, this documentation is really helpful for understanding what's included in the project. And that being said, let's talk about the one thing that I missed. A lot of us use GitHub. Actually, this template is only on GitHub. So you may use GitHub Actions. Now, if you're using this in production, you might use another continuous integration tool. But if you use GitHub Actions, I included some default workflows that test, I think, core checks against an Android project. So the first workflow we have, Android build. This is on every push. We just want to make sure that our build compiles. That's what assemble does. We want to make sure our unit tests pass, and then we want all of our lint checks to pass. So we do this for a Detekt, for Ktlint check, and for Android lint. So this is a GitHub Actions workflow you get out of the box. If you're developing your project exclusively on GitHub and you want to use Actions, you don't need to do any setup. Just copy this template, and you get this automatic continuous integration through GitHub Actions just by using this template. And there's a second workflow that only runs on pull request, which is to run the UI tests for the project. The reason I make this separate is because UI tests are a lot slower. And so that's also why they only run on pull request, is it's really whenever I want to make a big change, then we want to run those UI tests for us. And you can customize these actions as well if you want to change the like emulator level you're using, uh, things like that. So, and one more thing, the pull request template. I really like pull request templates. I think it's helpful for writing a clear pull request description. So I put a template in here automatically. What you'll get from this, I guess it's hard to show like a new pull request because I don't have another branch. But basically what this will do is when you create a pull request in GitHub, this markdown will be pre-populated in the pull request description. So it forces you when you make one to say, here's what changed, here's how I tested it, and if necessary, a reminder to add any screenshots or GIFs. But yeah, these are all tools that I think are crucial to every project, so I threw them in a template repo so that anyone who wants to build their own sample apps, whether you're starting a new production app or whether you, like me, want to do a lot of content creation and you want a quick way to spin up demo apps for individual concepts, then you can use this to get those demo apps up and running out of the box. So I hope that's helpful. I'm really glad I could do this walkthrough so that people aren't just cloning the template, but they can sort of do so in an educated manner and understand everything that this template has to offer and why. So do let me know if you have any questions. If you think anything is missing, drop comments below the video or submit an issue on the GitHub repo. I'm open to tweaking the way this template works if it helps a lot of people. I know that I've been very opinionated about my approach, but any more than this, I just want to be careful. I don't want to make it too complicated for other people to use, but I hope y'all enjoy that. Let me know what you think in the comments, and we'll see you again next time. Thanks. One small caveat that I left out, I just realized I ended that video so quickly. At the moment, we don't have any automation around changing the package name. So you may notice when you clone this repository, for example, and you go to like the source directory, you're going to see my name, Android app template. Just keep in mind that when you use this template, you'll want to refactor that. Hopefully we can automate this process in the future, but I just wanted to drop the caveat that that is not there yet. But all right, now we're really done. Have a great time.